Hi there, and welcome to Al and Merel.
My name is Merel, and I like to do deep dives into the latest research on neurodiversity.
And I'm Alastair, psychotherapist. I love creating metaphors and stories to help make sense of it all. And together we're going to be exploring the fascinating world of how neurodiversity shapes our lives. So let's dive in. So this episode of Al and Merel is brought to you by mycopilot.ai for when your willpower won't. So you know those 2 a.m. moments when you're caught doom scrolling and you know that you should really be going to bed? Or the sofa after work where you've collapsed and you're stuck on your phone? Well, MyCopilot AI is your personal AI co-pilot that will help you get on with the things that you really want and need to do in those moments. Whether that's doing the laundry, getting on with your projects or hobbies, or going to bed. Check it out at mycopilot.ai.
Just a note to say that we're explorers and storytellers. This podcast is not intended as therapy, advice, recommendation, or medical authority. We are just like you, inviting you along on our journey of trying to make a little sense out of fascinating research on neuroscience and neurodiversity as best as we can.
I can sleep on my left side now, which is nice. Yeah, I managed that for the first time about 3 days ago, and that was like, yes. So I think I struggle with inflammation a lot. I think my body is quite inflamed, and I think this is quite common for people with high cortisol and neurodiversity, and maybe this constellation of stuff that we might be talking about today. I've got it on my screen over here. That inflammation, I have oversized turbinates in my nose, and those are like, each side of the nose has these 4 sort of big flaps. They're not flaps, they're like bulgy bits that are involved in production of mucus and stuff. And when they get very large, they can block the passageway. When they get inflamed, that's because they're soft tissue, they just expand. And when they're already quite large, even the slightest bit of inflammation or running, any kind of stuff, immune response, boom, they go up. But one side of your nose at a time blocks itself a bit every 8 hours, and it switches side to side every 8 hours. So this is why you always have one that's working and one that isn't working. Like your body actually does that and switches them from one to the other on an 8-hour cycle. And like people don't know this, but it's hilarious. But when you lie down on your side, the turbinates are on the outside. So if you're trying to breathe through your left, if you lie on your side, those turbinates will, by gravity, just make a little bit more space and make it easier. And then if the left side is blocked and you lie on your left side, then the right turbinates fall in. So you're blocking the only nasal passageway that you've got even more. So you want to sleep on your right then so that the turbinates fall away. So if you've only got one nostril, it makes a difference. So, which side I sleep on matters a lot. And, if I can't sleep on my left side, any time that I'm breathing through my left nostril, I'm like, and I lie on my right, I can't breathe. And I'm like, then I have to turn around. I'm like, this is really uncomfortable, but I need to because I can't breathe the other way around. So, deep psychological stuff. Well, it's all related, isn't it? The psychology and the physicality. I think this is what this RCCX stuff is all about, really, is that actually at some level, the psychology follows basic body dysregulation. If the body can't manage stuff consistently, the mind follows.
So I think what I've been able to make of it was a bit overwhelming, to be honest, because it's kind of, she tries to create kind of an holistic approach. So that means that it's super complicated because it tries to include basically everything. But what it seems to imply is that it's not necessarily the same gene that causes all of these things, but that it's multiple genes that cause different things, but that they're in the same cluster, which mutates simultaneously. So if one of your parents has a mutation somewhere in that cluster, then it kind of influences the other genes in that cluster, and it's likely that their children also have mutation in that cluster. So they say, at least, that the CYP21 is coding for an enzyme that will have such complicated names, but it's coding for an enzyme 21 hydroxylase, which is associated with exaggerated stress response in the setting of low basal cortisol. And that is, okay, so I'm kind of...
Lots of arrows, aren't there, on these diagrams?
Yeah. Also, I'm not reading the diagram, but all of the text that was associated with it. like she wrote many pages on the internet, and then she also wrote a summary for scientists with this much shorter version, but also much more dense.
Right. This isn't like peer-reviewed papers, though, is it? This is a
No,
PhD student who's building a thesis, and
I'm not sure if she was a PhD student at the time.
Karen Herbert?
No, it was a collaboration with Karen.
Meglatheri.
Yeah.
Meglatheri.
So I think it's her. It's in the basis. It's her theory, Meglatheri.
And she's an MD, isn't she?
Yes, she's a medical doctor indeed, and it was in the basis. It was her theory, and then she posted it. She tried to publish it. Then it wasn't accepted because it was kind of too complicated, because journals tend to accept papers that are on a specific topic and have like a very clear.
Yes, they build it with little bits of Legos and don't give me too much complicated theory.
Yeah, exactly. And this is kind of a holistic approach that tries to combine everything into a huge theory. So it wasn't accepted anywhere or everything, it was kind of too broad. Then she posted it as a blog kind of thing on a web page on the internet, and got contacted by Karen Herbert. And then they collaborated on the second part. So a few years later, they posted on the same website a second version of the theory, which was a collaboration between the two of them. And that's kind of this theory. So it's a collaboration between the two of them. And I think it is mostly based on experience as a medical doctor and psychiatrist, with kind of a background in gene therapies. And it's referring to a few other papers as well, but not too many.
Okay. So the core observation then is empirical. So
yes, I think so.
Sharon Meglatheri noticed this commonality, was curious about it.
So I think the first thing that she noticed is that I think she was a psychiatrist as well, and she saw a lot of people with, like, for example, schizophrenia, autism, ADHD, other psychiatric stuff, and she noticed patterns in, like, also hypermobility, also inflammation, autoimmune diseases, and she noticed patterns that, like, all of the people that she was treating for psychiatric mental things, that most of them had all of these other things.
Yeah, and I think anecdotally that hangs together. I don't know many people on the neurodiversity spectrum who don't have multiple comorbidities. Like, usually even just the psychological labels, there's more than one, overlaps, question marks about, am I ADHD or autistic? Is the dyspraxia part of this? And multiple labels kick in. And I don't think I know anyone who doesn't have, but it's anyone I've spoken to about this, who doesn't also have something going on in their body. But there's a part of me that's like, the Descartesian split where we go, oh, mind is separate from body. I think we still struggle with that in our society, where people think their mind kind of exists in its own thing, like that it's its own entity, and that it just happens to be
that is separate from the body, you mean?
Tied to the body. And I violently disagree with that. I think all aspects of thought and cognition are deeply tied to body. Like, I don't think that the mind really exists without body. I think it's a reflection. They're reflections of each other, really. So I think it kind of makes, like, prima facie sense that we're going to find mad overlaps between what we're experiencing in our bodies and what we're experiencing in our mind. And if we've got stuff if we have mental experiences or psychiatric experiences that are disabling or different, or if everyone had this, then the world wouldn't function kind of levels of stuff going on, then those bodies would probably also have something going on that if everyone had that would be quite difficult for bodies to survive. So I think that's inevitable. The question is, does a little gene cluster kind of explain it? I mean, the sense I get from this is that there's like a bunch of genes that move together. So if you're going to get it from your parent, you'll get the whole block from your parent. If you get it from your other parent, you get the whole block from your other parent.
Yeah. So one of the things in this theory is as well that these genes, like in the RCCX cluster, that they are the most highly mutagenic part of the genome, because mutation of these genes provide novel ways of responding to ever-changing environments in terms of response to pathogens and brain wiring. It seems to be that this cluster is just mutates much more than other parts of the brain, or of the genes, sorry. And that makes sense in terms of evolutionary response to the environment, but that can also cause other things to happen that are maybe not that desirable.
So if it's highly mutatable, I think a couple of things jump out to me as potentially interesting considerations there. One of them is that it may not actually be existential, right? The RCCX cluster may not be existential, because if you mutate certain genes, the fetus doesn't survive. Like, that's why there's actually quite a lot of miscarriages. Like, we really don't talk about miscarriages, but they happen a huge amount of the time, because a lot of the time, actually, the genetic recomposition of the two parents' genes and whatever mutations occurred in that process isn't actually viable. It's nothing to do with the parents. It's just, hey, that particular combination doesn't make a functioning human being. Whereas the RCCX cluster may be, it doesn't actually kill the human. Like, it doesn't undermine the fundamental functioning of the liver. So at some level, it's actually quite superficial. And I think that's something really interesting about, these like neurodiversity. It's like there's quite a lot of difference in how we process the world, but it is actually quite remarkable that those differences don't undermine survival. Right? They are psychiatric, they're inflections, they're like high cortisol, low cortisol. They change how we behave, and they change the things that we struggle with, and how we attend, and how we process, and body stuff. But they don't actually undermine our ability to, at a really basic level, function. Obviously, if they get really intense, if you've got really severe autism, like level 3 autism, then you do need external support. But actually, a lot of us with autism, we keep ourselves alive just fine. So
Yeah,
that strikes me
I
as a
think
kind
it's
of low risk cluster to mutate.
and I think that also relates to one part that I don't fully understand. Okay, so one thing she says is low basal and spiking cortisol in utero and in infancy.
I saw that. That was surprising.
Yeah, so that low basal and spiking cortisol in infancy, so when the child is already born, that can lead to CYP21A2 mutation associated neuropsychiatric spectrum, or CAPS in short. And that makes you at risk for developing severe PTSD brain circuitry, which is kind of this wired for stress, wired for.
So it's almost like too much low basal cortisol and then high spiking almost creates too strong an imbalance when it spikes. It's like, wow. So the body just can't handle the cortisol, isn't well set up for dealing with it, so it gets kind of overwhelmed by cortisol when it happens, which I certainly recognize because I've had my cortisol tested and I'm out of whack, but not high. And I was very surprised by that, because I'm like, that's surprising, because I did quite a lot of research into cortisol. I'm pretty sure that that's why I've got hypermobility and all that stuff. It's highly correlated. And I've got mad joint issues because cortisol messes up your joints if it doesn't get absorbed fast enough, if it just floats around. But my baseline tests, nothing exciting to see, all quite low.
Exactly. So, but I think that, that's exactly what this theory is also suggesting. So that the base cortisol is usually low, but that it's very easy to have a very high spike by like any circumstances.
It's almost like the experience we have when we have like a lot of neurodiverse people have quite a low affect until they're triggered, and then they have a massive over-the-top affect. Do you think this is do you think at some level, like, I don't want to talk about genes as being like purposeful and directed, but sometimes it feels like that because of the way that the sort of systemic maths plays out over generations. But could it be the case that the RCCX is supposed to be like this, so that this is kind of what I was thinking you were saying earlier on, so let me check in with this. Is it supposed to be quite fluid so that we can adapt to high stress, and we need like a few generations of people who are just like hyper capable of dealing with that, but then we need to be able to calm down when everything's normal?
Yeah, that's basically what she is saying as well, that like this gene, this cluster is highly mutatable because of this purpose, that we should be able to kind of adapt to changing circumstances, to the environment changing to stress responses, because their stress responses, like usually changes in the environment cause stress responses because like we need to survive, and stress is required for putting effort in surviving.
It makes us pay attention. But
Yeah,
that's
exactly.
epigenetics about this as well. I wonder whether it can be switched on and off, because a lot of epigenetics is, the mother's body assessing the current environment and kind of flicking switches in the child's embryo to go, we're going to make this one like better adapted to high stress environments. We're going to make this one better adapted to, gentle environments. And like, that's kind of what epigenetics allows for. So I wonder whether epigenetics, whether RCCX is also then, highly influenced by epigenetics. Because I mean, there's an element where I'm like, I find it difficult because I'm like, at some level, if this isn't directed, right, if there's no kind of like puppeteer behind all this going, haha, we shall change this gene to make you more, then it's not like its purpose is to do that, but it benefits our species if we don't lock this stuff down. Because if we lock it down, maybe people actually start not surviving the stress. So it benefits us for this to be fluid. That's really fascinating. Is it a bit too over complex though? Is it trying to pull in too much stuff?
Maybe, but that's the reason that I was rejected from multiple journals. So it might be. On the other hand, it makes sense if we only look at, for example, the hormones that we talked about last time. Then these are relatively simple, but then also like dopamine and norepinephrine and serotonin and all these things also have pretty complex functionings, right? It's no single thing in the body just does one thing. So it kind of also makes sense that this is very much interacting, and all of these things have multiple consequences and interactions with other things, and then consequences indirectly. And I kind of, yes, I also feel like it's pulling in a lot of things, but it kind of also makes sense. And she does also divide it in separate things. So the only claim is that these genes are on the same cluster and that they mutate together. But she doesn't claim that all of these things are caused by the same gene mutation. It's separate genes that cause separate things, but they do mutate together. Like the hypermobility gene is a separate one from the psychiatric cortisol motivated stuff, but they do influence each other. So they're caused by a different thing. And then there's also the C4 gene, I think, which is associated with schizophrenia and inflammation, which is also a different gene, but also in the same cluster, so it's mutating together.
Yeah, interesting. So why would they mutate together? I guess you could theorize that there's some kind of like consistency metric. Like, for example, if one of them didn't mutate, if one of them went up and the other one went down, that might actually create an unviable embryo. Because I don't know, I'm trying to think like an analogy in like maybe like computer circuitry, where, for example, one gene makes all the wires bigger that moves everything around, but then at the same time, and that will have a certain consequence because maybe electrons flow more or information passes more, and that means the whole system. But
It
to do
influences
that,
the system.
you actually also need to like change the alloy of the wire, because if you don't change the alloy of the wire, then maybe it overheats because it's too big and there's too much resistance. So you need to like reduce the amount of an element in there. So maybe these genes all kind of flow together because they have to. Like if you increase the cortisol, then for your nervous system to function, you have to also kind of suppress something else. Otherwise, you end up with a system that goes out of whack. And maybe that's exactly what happens. So some people, their systems do go out of whack because one of them got mutated in a direction that's quite strong, but maybe didn't have the balancing force somewhere else, and you end up with schizophrenia kicking in. I mean, I'm just taking an example there, right? And maybe level 3 autism is like, okay, let's get the benefits of that. And we didn't get the mutation. It's like, oh, we needed the mitigating factor on this gene that balanced it out. And maybe those of us with sort of mild symptoms, we've got a mix there going, oh, this is a, and then of course, if they all relate like that, then it kind of makes sense that they move together, because the ones that move independently might create unviable embryos, and, like the neural development fails literally during the embryonic stage, and the fetus aborts because that happens.
Yeah, and also according to this theory, a lot of these things can still happen before the age of 5. So it kind
think
of
that's really super.
goes back and forth as well. So that there are some mutations of the genes, and that influences the behavior of the child and the way that it responds to the parents and the environment, and that like
Yeah. I mean,
influences.
also, your body doesn't, when you're born, a lot of your endocrine hormone systems, your neurotransmitters, don't yet know what the equilibrium state is. And your body actually decides what the equilibrium state is at some point after birth, where it goes, okay, a normal amount of cortisol is this. Therefore, my body will stay with this amount of, creators of this neurotransmitter and this number of uptake sites. And that's literally exactly what happened to me. So we moved around multiple countries and were effectively homeless because my dad was a journalist and we were just sort of moving around after him and between things. So for much of my second year, I had an extremely unstable childhood in terms of like consistency and solidity. And I'm like, well, go figure. I have all of the struggles and hallmarks of a cortisol imbalance that's induced at age 2 because it found the wrong equilibrium. And and because I've got the autism and stuff, I've probably got this RCCX cluster that's like makes me susceptible to that. So that also then is like another inflection where it's like those early years, we get the setup, but we also have to learn the equilibrium points, which means if we're vulnerable to it, then those little traumas of early year have a potentially a bigger impact, because it is crazy how some people can have an experience when they're really young that shapes their whole life as a trauma, and other people have exactly the same experience and it has almost no impact on them whatsoever. What traumatizes that, what we experience subjectively individually as a trauma, varies wildly, although there are big commonalities. If you're being abused when you're a child, you're probably going to have trauma. That's, if you have a very unstable life, you're probably going to have trauma, but people do survive it in different ways. So maybe the predisposition, this is the theory, isn't it, that this is all predisposition and likelihoods.
And I think a follow-up part on that is, so part of this, like in the diagram, in like the summary diagram, there's also this part where it says that if the kid has very high cortisol and as a result very low, so high spiking cortisol and low basal cortisol, then I don't know how this would work, but that in acute stress response, cortisol is not adequate due to like this low baseline, and then norepinephrine will be used to deal with stress, as kind of it will turn up higher because the cortisol is basically too low to have its effect. And then that in turn will cause PTSD like responses, because as like related to what we talked about last time, norepinephrine is highly involved in PTSD wiring and like storing the experiences and then the PTSD like responses. And people that have low basal cortisol will, according to this theory, be less able to adequately respond with their cortisol, and then in turn use their norepinephrine, creating a PTSD like response.
So what I'm hearing there is, cortisol handles stress, but stress isn't fear. Stress isn't, like that, like a kind of danger threat response. It's there's something challenging here that needs attention. We need to pay attention to it, and like energy management is under threat. But not necessarily existential. But if we can't manage that, if we rely on norepinephrine, last week we spoke about norepinephrine being about learning from fear. And if you've got low norepinephrine, then you don't learn from like bad rewards.
Or you won't respond to it adequately.
So if you then have a high norepinephrine to make up for the cortisol, then things that are stressful, like conflict in relationships, house moving, someone saying something maybe critical to you, these aren't actually threatening things, although they are a bit stressful because you have to do something with them and they kind of mess with your assumptions about how the world works and whether you're doing well and all that stuff. But if you're using the norepinephrine, you get high spike, then that turns those things into a actual fear, existential threat. And it
will be experienced as something fearful.
Exactly. So when people have really high triggers, like, you know, in ADHD, you might have RSD, you know, like rejection sensitivity dysphoria, where the smallest thing, even though it's technically non-threatening, is perceived as threatening. So that thing may be a bit stressful, but it's like, oh, I can't just assume that I can work with life the way that I want to. I've been challenged by someone. Small stress response should be appropriate there, because you're like, oh, I need to rethink something. But no, we see that as, oh, that is an attack on me and a threat, and like, danger, danger, danger. I must attack in reaction to protect myself, which is obviously a squiff relational response, but makes total sense if we're using
Norepinephrine instead of cortisol.
Deal with a situation. And that makes me wonder then, like, therapeutically, you know, can you if your cortisol is low, how do you know, is therapy ever going to help you move from norepinephrine to using cortisol to handle stress? Or is that just a complete fool's errand where you can't, and you just have to accept that the way that you deal with stress is through fear, and you need to learn to manage that, you know, like.
Yeah, well, I think therapy would mainly apply to like not firing huge amounts of any hormone at all. Like that you it should in the end like not be producing loads of cortisol nor norepinephrine. Like you shouldn't be firing any of those. Like to not make a spike, not make either of them spike.
I think I might argue that that's more a Buddhism thing. Like, it's like, I will not respond to anything. Yay! Who cares about cortisol and norepinephrine? I will just like chill through everything. I mean, it's a strategy. If you can pull it off, fantastic. Maybe.
Maybe that should be therapy. Never
It
mind.
might be part of therapy. Yeah. I kind of hope that this does end up having some legs, because it'd be nice to have a kind of coherent map, because I think that really helps people. You know, when you're just freaking out all the time and you think it's your own personal failures, you know, and you just go, oh, I just suck at being a human being, and it's because I'm lazy or I'm dumb or, you know, whatever it is, I'm shameful or I'm bad somehow, right? Then that absolutely undermines our ability to exist happily in life. Whereas if we can say, hey, you know what? Like, knowing about this doesn't make it go away, right? It's not like it's a magic bullet. But if it gives a map and goes, okay, I get that the reason, or one of the reasons that I'm overreacting a lot of the time is because I had some traumatic experiences and a predisposition, which means that my body probably isn't handling it in the way that is most effective to handle this. And I'm actually using a slightly different mechanism, which has its consequences. So, i.e., I'm not using cortisol, I'm using norepinephrine. I can then go, okay, I understand that that is the case. It's not a failure. And I can understand that it has consequences, which means I can start building strategies for managing that. It doesn't necessarily mean I can change it at a,
But at least
rewire it.
or you can see your life as like relatively successful with
Given.
all the things that you have to deal with, that your body, like your genes, that you have received certain genes, and that you need to shape your life according to them.
Like if you were, you know, if you were born with brittle bones and you happen to break your leg when you were a child, you're like, okay, the brittle bones is why.
Yeah, and you won't see yourself as a bad person. Yeah.
Yeah, it's not because I didn't look after myself or I'm stupid and you know, clumsy. It's that my brain will break faster than anyone else's. So if I knock myself on the edge of a table, that can break my bone. And it's like, you know, I'm not an idiot. I'm just really at risk. But then you end up with a limp because you've broken your bone, and that has all sorts of extra consequences that make life harder. And you're like, okay, so I'm not going to be a world-class athlete runner, but I can manage this. And actually, given this, I'm doing quite well. I need to set up my home in such a way that it has maybe got less sharp, you know, hard edges. And you can be like, oh, this sucks. But it's also like, yeah, but it's not my fault. You know, it's just not my fault.
To deal with it.
You do have to deal with it, because that's the thing about responsibility. Like, no one's going to fix it for you. You have to manage your own stuff, like, and find the people who support you to manage it, but they can only ever support you. They can't do it for you. But knowing what to focus on Because like managing an entire life, like, oh my God, there's so much stuff to do, right? Like you've got to sort out your food, you got to sort out your exercise, you got to sort out career, you got to sort out your sleep, you got to sort out, your trauma responses, your relationships. It's like all of those are full-time jobs just by themselves if you wanted to. And you have to do all of this. And if you know how to prioritize different bits without shaming yourself, I think that's very useful. So I'm kind of hoping this has some legs. Although at the same time, it's quite low level. It just maybe hints at some structures. I think there's a lot of thought needs to follow to work out what to do with this in therapy personally and stuff like that.
Yeah, see, there's just one reference in there that I still want to read, which, that's a study. It was a study on hypermobility, but then most of the participants also had either autism or bipolar disorder or ADHD or depression. And like, I think that's also related. So I think there's a few other articles that she's referring to that support small parts of the theory, but then most parts are not really supported by separate studies.
Yeah, it'd be interesting to do a bit of a deeper dive on which bit what in her theory is supported to what degree.
Yeah, exactly.
One thing that I have come across previously that I think is an interesting one here is the difference between a psychosomatic and somato-psychic. So, psychosomatic is basically imagining that you have a problem, like a physical ailment, and it doesn't exist, but it's all in your mind, quote unquote.
Yeah, but you still experience it.
And it feels like you have a physical experience as well. So there's a book, and I can't remember which one it is, that basically says or posits that neurodiversities are somato-psychic experiences. So, for example, if you've got hypermobility, your body can't hold itself together, right? It can't maintain.
And it will have mental consequences as well.
And specific ones, right? So if you physically can't maintain your shape and rigidity, then you're physically going to feel like loose and indeterminate in space, because for every given sensation you have, proprioception, your body might actually be in a slightly different position. So it's sort of unreliable. You can't trust yourself, and you can't stand up easily. You're always leaning on something because it's exhausting having hypermobility. You use something like 30% more energy just to stand still, right? So always leaning on something. That's remarkably similar to the psychological experience that people have, where they don't feel like they know themselves. They don't have a container. They're like, but I'm always slightly different. And they always need to lean on something external for support. And it's like, well, what if the mind is doing that because it literally perceives the world like that, because the body perceives the world like that, and the mind follows the body at a fundamental structural level, but then applies it to the mental world so that you use the same logic in relationships, for example, but it actually comes from the body. It's the body's experience being mapped onto your psychological world. And I subscribe to this. I think there's a lot of validity in that. I think if we find stuff going on in our bodies that is really consistent patterns, I think it's almost impossible for that to not reflect in our mind's experience somehow. And it's not psychosomatic. It's not that the body's loose because the mind is loose. It's somato-psychic. It's how can a psyche possibly experience, self-structure, solid, reliable, if the body doesn't? And if you don't have that, it's very likely that you will try and impose rigidity to try and make up for it. Like there's all sorts of little consequences of this, but it all just stems from simple fact. The body can't keep itself together, and the mind has to work that out somehow. And I think it
is an interesting one. I feel like it's a bit oversimplified because there's still many people who, for example, do have autism, but like not have hypermobility or something else. Although maybe many of those people do have, for example, sensory sensitivities.
And
like it can, yeah, exactly. It can of course be.
Yeah, I would wonder. So this is a speculation. I wonder whether hypermobility might be correlated with AuDHD specifically, like when you've got the overlap between autism and ADHD. I believe. purely anecdotally, my sense is that might be slightly more correlated, because I noticed that people who have like what I call kind of like more pure autism, like without ADHD or without significant ADHD pathologies, they're often much more rigid and solid, and they're more likely to lean in towards like the dyspraxia side of things, which is totally different from hypermobility, where you're very flexible and very fluid, and like the rigidities turn up in a different way. Like pure autism or single, I don't want to say pure, but you know what I mean, like, you know, the Venn diagram of autism without ADHD, they're often far more rigid, whereas if you've got the ADHD, there's just additional fluidity, and that's there. But then on the flip side, you've got people who are like truly ADHD who don't really have that much autism expression. I don't know. Are they quite hypermobile? No, so maybe
Not any of the people that I know, at least,
I
which
tend
are
to
quite a
think of
few.
it as often more dyslexic.
Yes,
So I
that
don't see a
is
lot of people
very
with
true.
autism and dyslexia. I see. Actually, no, there are, but it's commonly dyspraxia feels more common, and this is just anecdotal. I don't have the stats to back this up.
Yeah. That makes sense. But it does correspond to my anecdotal view as well.
So I guess if there is a cluster, then there might be common, like, stable configurations and maybe some ranges. So you get Venn diagrams where, you know, in the clusters, like these hang together commonly because they're mutating together commonly, and maybe beneficially so, or maybe just complete chance. Like, that is the history of our evolution. These things happen to be in the same place, and therefore they track each other because they move together.
Also, following the theory that we just discussed, like that stressful experiences in early childhood can then influence how stress responses in the rest of your life will occur, then of course the physical state of your body in the age below 5 will also influence what kinds of stress response you have, and will in turn influence like your stress response, which like if we see autism, ADHD, AuDHD in terms of stress responses to things in life, then that also like corresponds to this physical state of your body in early childhood. Because like if you're hypermobile, if you are super sensory overloaded all the time, if you're dyspraxic, that will influence what kinds of stress responses you have and what things you have stress responses to, and how your body and your mind are responding to these stressors.
Which is really
which might influence like which ones of the mental disorders or like states, whatever,
right.
are developing.
And that for me feels remarkably similar to the trade-off theory that I was banging on about on TikTok a while ago, where it's like your brain has only so much energy to handle stuff, right? And if it's struggling with a system or systems that are requiring like loads of extra energy, so for example, if your cerebellum cannot process a particular type of input well, then your neocortex has to do it. And if your neocortex is busy doing that, it's literally using energy that it then has to go, well, I've got a budget of energy, which means I'm now going to have to drop something else that just is deemed not as important. So if you've got something in your genetic profiling that makes one thing difficult to deal with because the particular neurotransmitter that supports that is undermined, or you've got a particular structure in your cerebellum that's good at doing this other thing and not that other thing, then you have to trade something else off. And things like time, memory, physical movement, like you can get through life without being too precise in your physical movement. During the developmental phase, the body might just go, listen, we're going to just develop that baseline, but we're not going to make a mad effort to be really awesome at that because it doesn't matter. And I'm too busy trying to work out how to adapt to this other really difficult thing. And if there's something in that RCCX gene that makes one of those systems that could be traded off, like a little bit weak already, then in just a sheer cost calculus, the brain may just go, that's already a bit shit. Or it's going to take too much energy to overcome. That's too hard already. I'm going to do the basics there. And obviously it's not like a conscious decision to do that, but like a systemic energy balance that just sort of does its developmental thing. But that might be why some of these common things that get dumped, because if they're already slightly undermined, then the brain's kind of going to trade them off and go, listen, I'm already going to struggle to be really good at fine motor control. I might as well not make too much effort there. So when you're learning as a 2-year-old, 3-year-old, you're just like, this will do. Whereas someone else who's got that is like, oh my God, I can really move my fingers. And this is so exciting. Totally different attention, like developmental attention to different systems. And, if numbers and language doesn't matter, dyslexia. Or dysgraphia, more accurately. Numbers, dyscalculia. If you're threatened in time, cortisol maybe is part of this one. Dyschronometria, which is executive dysfunction in a big way. So I think that's interesting because I kind of like the trade-off theory. I think it has a lot of experiential validity. It makes sense as an experience. A lot of people resonate with it. But I'm also like, how does that work at a kind of neuroscience level? Like, I've got some bits of it, but I'm wondering whether this RCCX kind of starts backing that up, or it's certainly consistent. Like, these things are consistent if there's an undermining. So I'm trying to wire them together on purpose. I mean, like, I'm looking for the story. So this might be complete rubbish, but I think somewhere down here is a sane story that takes the deep neuroscience to a level that ordinary layfolk can understand and go, I can actually use that to make my life better because that makes sense without needing to know what hydroxylase is. Hydroxylase. Interesting. I do hope it has validity. I mean, I'm sure that even if her particular offering doesn't end up being exactly correct, I imagine that there'll be some really interesting structures and insights there that will stay, even if some of them get refined out over time. But it's all moving the story on, isn't it? Thanks for listening to our podcast today. If you like what we're talking about and want to hear more, do like, follow, and subscribe. It makes a really big difference. You can also find us on social media and our Patreon, Al and Merel, or our website, alandmerel.com. Thanks for listening. Catch you next time.